Okay, so with the parallel lines and proportional parts, a lot of times these setups are going to be even easier than having to look at two triangles. So in the first one here, we have JK is 7, right? So that's this little piece up here. So if we can write in there, he's going to be 7 up there. KH is 21. JL is 6, and we want to find LI. So we can set up a ratio and cross multiply if we want, but we can see that if this small piece 7 times 3 is 21, then 6 times 3 is 18, and I know that's what a lot of you have been doing. I mean, if you wanted to call this x and set up your proportion, you can do 21 over 7 equals x over 6. That will work, but you can just see that 7 times 3 gets you to 21. 6 times 3, x must be 18, okay? Okay, and the next one, I have RU is 8, so he's this little piece down here. US is 14. TV is x minus 1. And then VS is 17.5. So you can almost see your ratio sitting here in front of you already set up for us, right? 14 over 8 equals, if I set it up over here, 14 over 8 equals 17.5 over x minus 1. Okay? And then we're going to cross multiply and solve. So when I multiply 8 times 17.5, if you have your calculator or even a calculator on your computer, you can do that. 8 times 17.5 is going to be 140. And then that's going to equal 14x minus 14. And this is pretty easy for us at this point. We would add 14 to both sides. Right? So we have 154 equals 14x. And then you can see x is just 11. So that's the first part, find x is 11, and then they said find VT. So if I wanted TV, actually, TV, so x would be 14, and then TV would be 14 minus 1. I'm sorry, x would be 11. X would be 11, and then TV would be 11 minus 1, it would be 10. Okay, if we had to do both parts of that, we find x and then find TV. Okay, so now in the next part, I just want to figure out if, so the next 3 questions are really just true, false, or yes or no, right? Are the 2 lines parallel? So the 2 lines that we're referring to, so the 2 lines that we're referring to would be BC and DE right here. I want to see if those 2 lines are parallel to each other. So we have to see if the parts are. So we're going to just set up what would be a truth statement and see if it works. So AD is 15. DB is 12. Okay, and then AE is 10, and EC is 8. So a couple ways I could do this. I have to see if this is a truth statement in front of me here. Is 15 over 10 equal to 12 over 8? So if I cross multiply, do I get the same thing either way? Is 15 times 8 the same as 10 times 12? So 10 times 12 is 120, and then 80 plus 40 is also 120. Okay, or we can just simplify these ratios, right? If I divide 10 by 2, I get 5. If I divide 8 by 2, I get 4. If I divide 15 by 3, I get 5. And if I divide 12 by 3, I get 4. So both of those are in the ratio of 5 to 4. So number 3 would be yes, they're parallel, or true. Okay, now I move on to the next one where I have BD. So BD is 9, he's up here. And then BA is 27, that's the whole thing, right? So be careful, not this piece is 27, this piece would actually be 18 because they're telling me the whole thing is 27, right? So I have 9 and 18. Then I come down here and it just says that CE is 1/3 of EA. Okay, so CE, this little piece here, is 1/3 of EA. Well, I can see right away that's not the ratio I have up here. What I have up here is that 9 is 1/3 of 27, right? 9 is 1/3 of the whole, or 9 is 1/2 of 18. So I don't know what these sides are, but I know that if EA or EC is 1/3 of EA, then that would be more like this is 27, the smaller piece, and this is 9. Okay, so an example of like two numbers that would fit that, right? For C, this would have to be like 5, and then this guy here would be 15. And that's not the ratio that this 5 is 1/3 of 15. That's not the ratio we have up here at all, right? 5 times 3 is 15, but 9 times 2 is 18. So this one would be a no, they're not parallel. Right? 18 over 9 does not equal 15 over 5. Okay, it's not going to work. So that one's a no. Okay, and then number 5, we have AE is 30. So he's this piece right here. AC is 45. So that's the whole thing, right? A to C is 45. So what I'm going to do is tuck 15 in here. Okay. Now I know the whole thing is 45. That's what they're told me. But it might be helpful for me if I know I have the two little pieces. Okay. And then they do the same thing. So this time they say AD is 2 times DB. So I'm just going to make up a couple of numbers here. Like let's say that this is 5. Right? They said that AD is 2 times DB. So this would be 10. So there's two numbers where the AD is twice DB, 10 and 5. And we can see this is also true here. 30 is twice 15. So this one's going to be a yes. They're cutting up proportional parts for us. So those are parallel lines. Okay, in 6, 7, and 8, we have a new term that we looked at, which makes a lot of these problems a lot easier for us. It's the mid-segment. Okay, so they tell me that JH and HN in both of these are mid-segments. So JH is a mid-segment. HN is a mid-segment, and then here we have JH and HN. Okay, I don't have an HN over here. But the thing with the mid-segment is there's a couple things that happen. It connects midpoints, first of all, right? So if I take a midpoint of this side and a midpoint of this side, there's a couple of results from that. Number one, you're going to have parallel lines. This segment here is going to have to be parallel to that segment, which means we're also going to get proportional parts. So this piece, like if I took these two ratios, they're going to be proportional to each other. But probably the best thing about it, which will probably get us through all three of these questions, is that this mid-segment is always 1/2 of that other side that it's consequently parallel to. So in this case, x is just going to be 15. So here we get x equals 15. All right, and the next one, JH is 9. JH is a mid-segment, so it's connecting the midpoints. It's parallel. So 9 has to be half of x. So x here would be 18. Okay, and in the last one, they get a little fancy for us, but remember we had JH and HN are mid-segments. So if HN is also a mid-segment, then that means it's hitting a midpoint. So this other piece has to be 8. We've got 8 and 8. So the whole segment here is 16. X is also a mid-segment itself, so x has to be half of that 16. X is also 8 in that case. And in 9 and 10, we're going to set up equations to solve. Okay, so in number 9, we have our parallel lines, proportional parts. We could say 2x plus 1 over x plus 7 equals 3y minus 8 over y plus 5. No, that's not going to be solvable. But I do have that 2x plus 1 and x plus 7 are marked congruent to each other. So if 2x plus 1 and x plus 7 are marked congruent to each other, I can go ahead and take that equation and use it. And then remember that I have proportional parts. So if those two pieces are congruent, then the 3y minus 8, even though it's not marked, has to also be congruent to y plus 5. So we solve both of these equations. Pretty easy solve. In the first one, subtract x, subtract 1. So we have x equals 6. And in the second one, we've got y. I'll subtract that. And I'll go ahead and add 8 both sides. So I have 2y equals 13. So a sneaky little decimal, we get y equals 6.5. Okay, and we can really basically do the same setup here. We have our one equation where they're telling us that they're equal to each other, so we can start with 2y minus 1 equals 3y minus 5. Okay, so we subtract 2y, and then we would add 5. So negative 1 plus 5 is a positive 4, and that just equals y. Okay, so we have y right away there. Then our second equation, we do get a fraction involved there. We're going to have x plus 3 equals 3 halves x try that again. So you could work with the fraction here. You could subtract 1 from both sides, bring all the x's. You get to your answer pretty quickly. If you want to use the trick that I showed you in class to get rid of the fractions, we can do that. Remember, the idea here was the problem is that denominator of 2. So I'm going to multiply everything by 2. This is where you have to be careful. If you multiply everything by 2, don't miss anything. So we need 2 times x. That's 2x. Then don't forget we need 2 times 3. That's 6. Now I need 2 times 3 halves x. Okay, the 2's just divide out there, and I get 3x. And then the last 2, don't forget 2 times 2 is 4. Much easier equation, in my opinion, to solve than what we started with the fractions. We subtract 2x, and we're basically done. Okay, and then also subtract 4 from both sides. 2 x's go away. We have 2 equals x, or 1x. Okay?